Hello everyone. So this is Code Runner. So in this video we have to uh, try to do this question, that is rotate oranges, and I will try to explain this question in a different manner. So we have so first of all we will understand the question, and after that I will share my approaches, and according to them we will try to code with my approach. Okay, then so let's get started. So this is code runner. So in this video I'm going to explain this question, that is rotten oranges. So this question is basically medium level question in the lead code. So in this question basically what we have given, and we have to find the minimum number of minimum time to rot all the oranges. So in this question we have given an m cross n grid. So m is here representing the row, and n is representing the columns. Okay, so we have given n cross m grid. So and these are the values that will 2 will represent the, that is rotten orange. Okay, and 1 will represent the fresh orange, and 0 will be representing our empty cell. Okay, and every minute, and we have given this condition, that is at every minute, if the fresh orange is adjacent to the rotten orange in 4 direction, that is upward, downward, left and right, it becomes rotten. So okay, so we have to find the minimum number of minutes such that none of the cells has a fresh orange. So if it is not possible to rot all the oranges, so we have to return the -1. So let's take this example. So with the help of this example, I would like to explain my what I can say. I would like to explain this test case with the help of example, or we can say with the help of this example. So we have given this grid, that is m cross and grid. So let me draw this grid. So this is m cross and grid. So our rows and columns are 3 by 3. So this is 3 by 3 matrix. Okay, this is 3 by 3 matrix. Okay, so we have given the first, that is 2 here I will writing this 2 is representing the rotten oranges. Okay, here 2 is representing the rotten oranges, and 1 is representing the, what we can say, fresh orange, fresh orange fresh orange, and 0 is representing the empty space between them na. Okay, 0 is representing the empty space between them. Okay, yeah, 0 is representing the empty space between them, or we can say empty cell. Okay, I'm writing this in the short form, that is empty cell, that is EC, and this is F, that is fresh orange. Okay, this is R, that is rotten orange. Okay, then we have given 1 1 that it is empty cell, and this is 1, this is 1 1 0 1. Okay, so this frame is at time equal to 0. Okay, at time equal to 0 we have given this condition. Okay, so we have to find the minimum number of minutes or minimum time taken to rot all the oranges. Okay, so a rotten orange, in the question we have given the a we have given this that is condition, that a rotten oranges can move in the 4 direction, that is upward, that is left, right and upward and downward. Okay, so basically it means a rotten oranges can rot oranges to its all 4 direction. Okay, so uh, let me draw and another grid, that at time t equal to 1. So this orange, that is, let me draw the at time frame t equal to 1. Okay, t equal to 1, my grid will look like that, look like this, that is 2. Okay, uh, so this is empty space, so this remain empty, and this fresh orange become rotten. Okay, so in this case we will, what we will this rotten oranges will do, it will rot all the oranges to its all 4 directions. So it will rot this one. So this orange, this fresh orange will turn into rotten orange. So this will be 2. Okay, 1. This is 1. This is 1. And this is 101. Okay, at time equal to 1, my this grid will be look like this, that is 2 oranges are rotten. Okay, at time equal to 2, at t equal to 2, what we will do, we will rot the adjacent of this rotten oranges, that will be this, these two become 1. Okay, these two fresh oranges become rotten. Okay, will become rotten. So that is 2 2 2 2 2 2. Okay, that is 101. Okay, so now we so at t equal to 2, our this grid will be, that is one fresh orange will be left, and at t equal to this is 1, sorry, this will remain 1. Okay, sorry, my bad, this is 1. Okay, at t equal to 3, uh, at t equal to 3, this fresh orange will also turn into our rotten oranges. So so this will be 2 0 2 2 2, and this will be also 2. This is 0, this is 1, and this is 1. Okay, at t equal to 4, this fresh orange will turn into rotten. So you have one thing noticed, that our we do not, or what we can say, uh, one fresh orange is left into my grid, that is this, at this cell one fresh orange is left. So we are not able to rot all the oranges, so we have to return the -1. Okay, so in this case we have to return the -1. Okay, because we are left with one for fresh oranges. So at t equal to 0, at t equal to 0, my grid will be at this place, that is at this stage. Okay, all right. So we have to if we are not able to turn, or we can say we are not able to rot all the oranges, so we have to return -1. So in this case we have to return -1. Okay, so in this case we have to return -1. Okay, let's take the example in which we are able to rot all the oranges. Okay, so let's take one example. Okay, so let me take one example, another example, that is let me erase this first. So this is 2 1 1. Okay, this is 1. So this is 1. So I am overwriting in this example only, so we have to, what we can say, I have to do work less. So this is 1, this is 1 2 1 1, 1 comma 1 comma 0, this is 0. Okay, this is 0, and this is 1 1 1. Okay, this is at the moment of or we can say at the time frame of t equal to 0. So my grid will be this, and t equal to, at t equal to 1, so this rotten orange will rot the adjacent orange, that will be this will be also turned into our 2, that is rotten orange. Okay, this will be 2, that is 0, this is 0. Okay, uh, this is 1, so this will be 1. So this will be 1. Okay, so at t equal to 0, so what we have to do, we have to route the oranges to the adjacent of this 2, that is 2 2 and 2. Okay, t equal to 0. At t equal to 3, so we have to route this. Okay, there is 1 1. Okay, this is 0. Okay, at t equal to 3, so at t equal to 3, at so this will be this will route the adjacent array, so this will, so this here 2 will be 2, so this is 0, this is 2, this is 2. Okay, one fresh orange will left at t equal to 4. That fresh orange will also turn into my this rotten orange, so this is 2. Okay, this is 2. So here we are taking the we can say 4 minutes to rot all the oranges, so we have to return this time. Okay, we have to return this 4. Okay, so simply what how we can done this question. So I hope you are what we can say, you are understood this question, you are able to understood this question. So how come so how we will solve this question, so what are the approaches, or we can say what we can do for solving this question. So one thing you have noticed that this at time interval 1 2 or 3 we are exploring the adjacent node. So and these and and these time let map this time frame to our to levels. So we are using the BSF algorithm, because here here in this question, so we have given a time frame. So okay, time frame, and this time frame I can map with the level wise. Okay, level wise. So here what we are doing here is we are doing level wise traversal. Okay, we are moving left, right, or we can say all in 4 directions. So we will use the BSF. Okay, BSF algorithm for solving this question. So what will be my approach will be simply we will I will what I will take, I will simply what I will do, simply I will try to solve this question with the help of the BSF traversal. So what I will do, simply I will take the queue. Okay, so you all know that this BSF traversal use the queue data structure. Okay, so queue data structure is first in first out data structure, that is that has first in first out data structure. Okay, principle. Okay, so what we will do, we will store our that is pair of rotten orange that will be given in the question, pair of we can say coordinates of the pair coordinates of the rotten oranges along with the time. Okay, along with the time. So at the first moment, so we have given the that is one rotten oranges that is present at 0 comma 0. Okay, at 0 comma 0 cell the first rotten orange will present, that is 0 comma 0. Okay, and at the time that is time t equal to 0, so we are what we are doing so we are simply inserting my this inserting my coordinates along with the time interval. So this is representing the time, and this is representing the x and y coordinates of the rotten oranges that will be given in the question. So I will take the exam that is q in the form of pair comma int. So I will take the q. Okay, I will take the q, and that will be in the form that is pair. Okay, inside pair that will be another pair that will be storing our coordinates of the rotten oranges. Okay, that will be given in the question, along with the this integer that will representing our that is starting time, or we can say total time. Okay, so what we will do simply, we will insert this pair, or we can say pair along with the time with the q data structure, that is 0 comma 0 comma 0. Okay, 0 comma 0 0 comma 0, and what we will do, pop this pair with the, and pop this pair, and we will try to explore the neighbors of this pair. Okay, we will try to explore the neighbors of this pair, and if we are what if we are what we can say, if we are getting the this grid, that is um if we are moving in the grid, okay, and we are first of all what we will do, we will uh, count the fresh oranges. Okay, count the fresh oranges. So I will explain with the help of this code. So let me copy this code. Okay, so let me copy this code. So here what we are doing here is, first of all we are taking a time, that will time variable that will be indicating our time to rot the oranges. Okay, and secondly we are defining the row and columns. Okay, then we are taking this q data structure that will be storing our pair of the or we can say coordinates of the rotten oranges along with the time. Okay, then we are taking this fresh oranges variable that will be starting from the 0. Okay, we will count the fresh oranges, and we will make decision according to it. Okay, if our fresh oranges at the end, what we are doing at the end, if we are getting the fresh oranges equal to our rotten oranges, then means we have rotten all the oranges, so we have to return that time interval. Okay, to which we have rotten that all the oranges, so we have to return the time interval. Okay, so in the next this what we are doing here is we are storing the coordinates of the rotten oranges along with the time 0. Okay, starting, because we are starting with the 0. Okay, as we have to what we are counting the fresh oranges. Okay, okay, and this condition is when we have all the rotten oranges, or we can say we haven't any rotten oranges, so we have to return them 0. Okay, and in the next line, that is this dx and dy. So let me explain this. So let this is my rotten orange. Okay, this can, in the question we have given that we can move to upward, downward, left and right. Okay, so the coordinates of this, the possible, or we can say possible coordinates of this x comma the rotten oranges present at x comma y will be, that is this will be x plus 1, x plus 1 comma y, and this is x minus 1 comma y. Okay, this is x y plus 1. Okay, this is x minus x comma y minus 1. Okay, these are the possible moves that can be, we can say, these are the possible moves that can be taken by the rotten oranges to rot the orange adjacent oranges. Okay, so these are the possible moves. Okay, so here 0 plus 1 will be representing the this what we can say, the x is minus 1, so this right, that is this left coordinate is representing minus 1 comma 0, and this, so so what we will do, and what we will do, the pair which we have inserted inside the cube, we will pop that pair pair, and look for the adjacent pair, we can say adjacent neighbor of that pair. Okay, we will try to explore the neighbors of that pair. Okay, so we will the front element can be, what we can say, can be given with the, that is q dot front front element can be, that is q dot front dot first comma first, that will be our that is x coordinate, and that this second coordinate will be come with the this q dot front dot first dot second. Okay, then t will be represent t will be come with the q dot front dot second. Okay, q dot front dot second. Okay, so what we are doing here is, we have the, let's say this is q. Okay, so we are inserting our pair, that is rotten oranges coordinates, along with the time interval, that is 0. So how can we access this element? So this element can be accessed with the help of this statement, that is q dot front. Okay, q dot front will give this whole pair. Okay, so q dot front dot first will give this pair. Okay, 0 comma 0. And if I want to if I want the x coordinate of this pair, then what I have to write, dot first. Okay, if I need the second coordinate, that is y coordinate, then I have to write the this in place of first I have to write the second. Okay, so once I have get this x and y coordinate, then what I will do, pop this element, pop this pair. Okay, pop this element from the queue, and we will try to maintain the time of that is try to update the time along with the current time. Okay, so and and from this, and we are able to move, so we are able to move in the 4 directions. So we will what we can say, try to explore the new coordinates. Okay, try to explain the new coordinates. Okay, so we there are 4 possibilities for moving the at the given cell. So we will try to explore all the 4 possibilities. Okay, then we will check the condition if our this move is valid or not. We are supposed to move in 4 directions, so we will check if our move is correct or not, or we can say it is inside our grid or not. Okay, so what I have written here is, what I have written in this condition is, first of all, our this new coordinate should be greater than 0, of course, and this will be less than this row. Our new row is less than the total number of rows, and this is also for same for the columns. And this condition, that is our new our new cell will be should be 1. Our new export cell should be 1. Okay, if this is true, then we have to push that pair inside my queue. Okay, then push this pair inside my queue, and then we have to update that into the grid, that we have rotten that orange. Okay, and we have to decrease the count of fresh oranges. Okay, because we have rotten that fresh orange, because we have rotten that fresh orange. Okay, we have to decrease the count of that fresh orange. Okay, then at the end, if I get this fresh orange that has count greater than 0, means there is the remaining fresh oranges in the grid, so that will be returned -1. Okay, if we are not able to, what we can say, not able to rot all the oranges, so we have to return -1, else we have to return the time at which we have rotted all the oranges. So this is my approach for the DFS, with the help of the DFS algorithm. So you should try to first of all try try this question on your own. Okay, then you should dry run this question with your own. Okay, so let me meet in the next video. So that's for this video. So thank you so much for watching. So let's meet you in the next video. So till then, bye bye, take care.